Thank you very much for clicking on this video. And if you're a returning subscriber, welcome back. If you're just seeing our video for the first time, welcome. This is LFX, where we talk about how to find your X, which is your problem. So in today's video, we are going to look at this particular problem now, which is our X now. So for now, we have the question is which of the following physical properties increases across the following table. So now I'll have A, ionization energy, B, electron affinity, C, electronegativity, and D, atomic radius. So for me now, I cannot just come straight and start answering this particular question. What I'm going to do is that I'm going to explain all these things for you. So anytime you come across this particular question, or anytime you come across any of these questions that has to do with all those things, all this ionization energy, electron affinity, electronegativity, atomic radius, you won't find it very difficult. This is under a topic called periodic trends. So I'm going to explain something for you now. So let's draw a sketch of how the periodic table look like. I'm not talk about how it's going to be. So how our periodic table have 4 blocks, which is X block. So our S block look like this. We now have our D block, which is found in the middle. We now have our P block. I will now have our F block. So this is our S block. This is our D block. This is our P block. And this is our F block. Now, for now, when we talk about periodic trends, all these things, you just have to do it. When we talk about trends, let me talk about trends first before we now get over to this. Trends means something that changes. You have something like this, you have something like this, and something is moving from here and reaches here and change. This is a trend. Moves here and move again. This is a trend. This is a trend. So something that as it's going down or as it's going across something, a path, it changes. It's not constant. That is called a trend. Now when we come to periodic table, the trend here means some particular properties that changes, as you're even going across this particular side, because we have periodic table which is have periods, and here is this, like this is periods, and like this is what is group. So now there are some properties when you are going like this changes. There are some properties when you are going like this changes. There are some properties when you are going like this changes. So we're going to talk about those properties. Then we'll now go back to get back to this question. Then we have properties like we have properties you can see in atomic periodic table. We have something like atomic radius. Then we have something like electron affinity. We have something like ionization energy. We have something like electropositivity. So we have something like electronegativity. So let me stop here. Let me just talk about the atomic radius. Now, coming to the atomic radius now, let's talk about atomic radius. Atomic radius has to do with distance between two half nuclei. This is a two half nuclei, the distance. So now let's now talk about how it changes as in our periodic table. Now, if we are moving, look at our periodic table now. This is our periodic table. Now, if you are moving like this, coming down, the atomic radius will be increasing. The atomic radius will be what? Will be increasing. Now, if you are going like this across the periodic table, the atomic radius will be what? Will be decreasing, because there is now more number of electrons. Because for example, now let me give you an example. We have something like let me just use here we have hydrogen, helium, we have lithium here. Now from lithium to something like boron, lithium will just have something like 3 electrons. Lithium will just have something like 3 electrons. But when it comes to boron, because boron will now have 5. But now they are already having the same number of shells, right? The same number of shells. So where do you think that there will be more pressure? There will be more pressure on this particular side.
which will now make their atomic radius to be smaller. So as they are going across the periods, the atomic radius will decrease. So that's for that particular one. So as they are going like this, and it's increasing. But as they are going from here to here, the atomic radius is going to be decreasing. Here increasing, here decreasing. Now, because I don't want this video to be very, very long, because we have a video, we are going to release a video on periodic trends. So let me just show you how the arrows will look like, so that this video won't be very long, so we can just show this question. So we have another one, which is electron affinity. So when it comes to electron affinity, as they are going up here, the electron affinity will increase. What is affinity? Affinity has to do with urge. So when we talk about electron affinity, urge for electrons. So as they're going up here, remember fluorine is around here. Oxygen is around here. There will be much urge for electrons around this particular side. So as they're going up this particular distance, the electron affinity will going to increase. But as they're going like this, electron affinity is going to do decrease. As they're going from this right to left, it's going to decrease. But as they're going from here, the urge for electrons will increase. There's no urge around here, because here is going to be full of melters. Melters donate. So there's no urge around here. So where the urge will be in this particular ones that needs electron, which is where there is where the electrons, as in there is non-melters back here. So as I'm going like this, it's going to increase. As I'm going like this, it's going to increase. The next one is going to be ionization energy. It has to do with energy requires to form a ion. Which side is likely to form a ion? Is this particular side again. We have this particular side again is one that is likely to form a ion very, very fast. So here now, the ionization energy is going to be increasing as they are going up. Ionization energy is going to also increase as they are going from left of the periodic table to the right of the periodic table. The same thing is going to apply to electronegativity. Let me tell you a secret. Electronegativity, electron affinity, ionization energy will always be pointing at the same side. Now the secret again is that you should be using where fluorine is in the periodic table to know where this particular this thing increases. Look at where fluorine is. As you are pointing up, the electronegativity will be increasing because of this particular man here. The same thing will happen in ionization energy. The same thing will happen in electron affinity. All those three things, these three factors are listed. The electron affinity, the ionization energy, negativity is going to be increasing as they are going up the group. What will they be doing as they are going down the group? They will be decreasing. Be looking at this fluorine. I know this is always confusing, but fluorine now, look at this fluorine. They are going up towards fluorine side. That means they will be increasing all these three factors. Now the next thing is going to be electropositivity. Where do you think electropositivity this thing will going to be? Where do you think? Is it going to be increasing towards this side? Is it going to be increasing towards this side? Or is it going to be increasing towards this side? Leave it in the comments below. Now let's now go back to this particular question. Which of the following physical properties decreases across the following table? Decreases. So we have one, we have ionization energy, we have electron affinity, we have electronegativity. What do you think is going to be the answer? The answer is going to be atomic radius, because it's going to be decreasing across. Remember I told you that as it's going to be occupying more electrons, there will now be pressure. The atomic radius will start decreasing. So if you enjoyed this video, make sure you leave a like, subscribe. See you next video. Thank you very much, and let's keep finding X effects.